Dismiss diyemeyecek miyim? Okay, guys, listen up. Thanks for coming. Today I am going to talk more about medieval technology. Aside from science, we will start talking about technology and later technologies as we get closer to newer years. So there is difference between technology and science. Technology is the application of the science. Science includes philosophy and mathematics, astronomy, etc. But technology is more into daily, fulfilling the daily needs, providing tools and techniques for the actual life, usable techniques. In terms of philosophy, it is kind of significantly different because technology is more materialistic. On the other hand, science is mostly due to curiosity, not for selling something, not for solving a particular day-to-day problem, although they are related. First technology examples are seen in Mesopotamia, Egypt, China, India, Greek and Roman places in Mediterranean, in Islamic world, South American also have seen some technological advancements. For example, in the Islamic world, there was hydropower, wind power, mills, değirmen, paper making, spinning wheel like the one that lady uses, automated instruments, automated music players, and simple robots, robotic automated behaviors of machines driven usually by clockwork or water power. So using water power, Gebze, for example, invented programmable robots so that you can change the behavior of the robot by turning on and off certain places, by switching certain places, so the behavior changes, automated behavior changes. In the medieval technology, clocks were, and steel work and clock was interesting. Mechanical clocks, spectacles, and vertical windmills with human power or animal power or water power or clock power, steel spring power, became popular. Ingenious people were made things like some items were found like watermark or the functional button. When the button is pressed, some operation is performed. Different button is pressed, another function is executed. So, like subroutines we have been talking, buttons are connected to certain functions or arms, certain functions. Furthermore, science and technology driven partly by navigation and sea explorations. And sea exploration means ship technology. Ship technology included sails, compass, rudders, astrolabe, and furthermore exploration with the regular horses included technologies like horseshoe, null, technological advancement. Also, the armory, where people wear during the fight. In the medieval time, significant this is not enough. Significant advancement has been done. I will fix it. Significant advances were made in military technology with the development of plate armor, steel crossbows, and cannon. Top. Crossbows, ok, çelik oklar, yay, and plate armor. The Middle Ages, perhaps the best known for also architectural heritage. So cathedrals, big buildings were made in medieval time, mostly in Europe. While the invention of the rib vault denilen şu şey, kubbe, rib vault and pointed arch gave rise to the high-rising Gothic style. Ubiquitous medieval fortifications gave the era the almost proverbial title of Age of Castles. So castles were built during medieval times because of local protection of certain people. So castle technology, castle making technology with opening doors, gates, etc., were made with the defense mechanisms. Although paper was invented in very early time, in the modern way of making paper first appeared in China in 2nd century after Christ. 2nd century paper was invented, and it was carried to Middle East with a group of Chinese paper makers were captured in the 8th century. That's what time it's. That's probably Turks captured by Arabs and converted to Islam. So the paper making were probably transferred those times in the 8th century, 7th and 8th century. Paper making technology was spread to Europe by the Umayyad conquest of Hispania. So paper making were spread to Europe from Spain. Before 8th century, there was Bible, there was other things. What was different? There was still paper in other forms, but the technology of making paper was very crude and limited, so that it was so expensive for regular use. Paper mill was paper factory. Paper mill was established in Sicily in the 12th century in Europe. The fiber to make pulp for making paper was obtained from linen and cotton. Then spinning wheel drum was invented with the increased supply of rags, and which led to cheap paper, which was a factor in the development of printing. So cheap paper was very important in both writing by hand people and the scientists and the technology people, and also in government, plus it was a factor for development for printing, early forms of printing. A set of European artifacts and inventions that spread through the Renaissance period, about the 14th century through the 16th century. So 1300s and 1500, 1300, 1500, 1300, 1400 and 1500, 300 years is the Renaissance period. That era is marked by profound technical advancements such as the printing press. Printing is the key. Linear perspective in drawing. That's interesting. It is invented by Leonardo da Vinci, Donatello. Distant objects appear smaller. Close objects appear bigger because our eyes see environment that way. In the earlier pictures show, like miniatures, earlier pictures shows everybody in the same size. Even if it is far away, it was drawn with the same size. But after Renaissance, perspective technique is invented, so distant objects are drawn smaller with a certain rule. Perspective lines were drawn, so you calculate the size of you estimate the size of the object and you draw accordingly so that it will perceived as it was far away. Leonardo da Vinci at the same time, again, and other technological people, inventors, drove a lot of mechanical devices and inventions. Some of them are unimplemented in papers. So drawing and inventing certain things were becoming more and more found. Renaissance science introduced the scientific revolution. Science and technology began a cycle of a mutual advancement. Before, as I said, science and technology was kind of different. Science was more philosophy related. Technology was day-to-day, like bread making, okay? Salt making, so chemical technologies, or gold extractor. Those are technologies for daily routines or construction. In Roman period, for example, in Roma, science was not that much advanced, but technology was advanced. So they were building a lot of roads, buildings, etc. But they didn't think about life. They didn't try to understand human body, etc. or astronomy. But after Renaissance, science and technology came closer and they moved together. So mid of the 15th century is important. In the mid of the 15th century, in the mid of the 15th century, printing press, firearms, and compass come in many places. I'm trying to show 15th century here, but no luck. I have it. Yes, I have it. Yine bir hikayeler oluyor ama. Yine iki team'imizi kaldırmadı arkadaşlar. diyeyim. İşte. Durdur. Tekrar bastır. Ekranı paylaş. Yayını başlat. Şimdi olacak. And the technologies that developed in Europe during the second half of the 15th century were commonly associated with the authorities of the time, with a key theme in the Renaissance thought, the rivalry of the moderns and the ancients. So that is the fight between old and new. Fight between old and new was the main idea. The Renaissance. Three inventions were popular: printing press, firearms, and press. They were indeed seen as evidence that the moderns could not only compete with the ancients, among them, for example, at the beginning, Ottomans, but had surpassed them, for these three inventions allowed modern people to communicate, exercise power, and finally travel at distances unimaginable in earlier times. They were able to travel, they were able to conquer, and they were able to exchange information. One famous technological advancement in those years, in the 15th century, is crank and connecting rods. Crank mechanism. So something is rotating. When something is rotating, some arm is connected. So as this rotates, the arm goes back and forth or up and down. So rotational motion is converted to linear motion or vice versa. That is what we call crank and the connecting rod. It converts surface motion into reciprocal motion, is of utmost importance for the mechanization of work processes. It is first attested for Roman water-powered sawmills, testere. So they were cutting things with the power of water from the river, like we show in the figure on the left. So that is sawmill. They can cut. They can cut stones. They can cut wood. Anything mechanical, power, water. During the Renaissance, it is also improved, refined. Connecting rods are applied to double compound cranks, double arms, while the flywheel is employed to get off these cranks over the dead spot. So there was a dead spot at one end, another end. So two things were connected to each other like an engine. So the dead spot can be achieved with the flywheel using inertia. Early evidence of those machines appear, among other things, in the works of the 15th century engineers, such as Hossit Wars, Anonymous of the Hossit Wars, and Takola. That is in the internet. That's on the internet. During Renaissance. On the right, top right, what we see is crank and the connecting rod mechanism for the sailboat, modern sailboat. Later, cranks and connecting rods became an integral part of the machine design and are applied ever more in elaborate ways, very different ways, even today. In 1588, we have a drawing showing 18 different applications, a number which rises in the 17th century, Theatrum Machinum, by Böckler to 45. 45 different use of crank and connecting rod. Kind of machine. This is one example. This is water pump. And 16, this is Böckler, that guy. Using water power, you can pump water in elevated height so that you can send the water to somewhere else. Tulumba yapmış. Sağ tarafta tulumba bağlısı. The famous Gutenberg, German goldsmith. Goldsmith means gold processor. Sarraf. So they melt gold, so on. Goldsmith, Johann Gutenberg. He was regarded as the single most important event of the second millennium and one of the defining moments of the Renaissance. Printing revolution that sparks throughout Europe, works of a modern agent of change, printing revolution, in the transformation of medieval society. For transformation of medieval society to Renaissance was ignited by the printing press. That is the same year with the capture of Istanbul by Fatih Sultan Mehmet. The effect. Relatively free flow of information extends borders and induced sharp rise in the Renaissance literacy. Significant increase was obtained. Significant increase. Learning and education. The circulation of ideas among the rising middle classes, but also the peasants, threatens the traditional power monopoly of the ruling nobility and is a key factor in the rapid spread of Protestant Reformation. So worker classes started to read and they started to think. When they started to think, they started to disobey to Christian church because Christian church was very powerful on the peasants in Germany. Dawn of the Gutenberg galaxy, start of the Gutenberg galaxy, the era of mass communication is instrumental in fostering the gradual democratization of knowledge that sees for the first time modern media phenomena such as the press bestseller emerging. So there were bestseller things, books. Everybody was to read that book. Since the books were relatively expensive, they were also exchanged between people. Renaissance book printers were also trying to make their books as artistic as possible. So they were making also a piece of art plus the book itself. The content of the book plus the book itself was worked very well. Newspaper. 16th century, meaning 15 something. It's about, again, Celali isyanları in Ottoman times, social democratization issues. So 16th century sees rising demand for up-to-date information that cannot be covered effectively by circulating the handwritten news sheets. Instead, from the slow copying process, Johann Carlos of Strasbourg is the first to publish German language relation by using a printing press. It was a relation. rather than newspaper. So before hand-printed, hand-copied documents were rotated in the public, then they started using printing press to circulate the notes to public. So it became later newspaper because it contained news. Newspaper becomes newspaper. 1618 and later, enterprising Dutch printers take up the practice and begin to provide English and French market with translated news. So they translate news in Europe, in certain cities, certain thing happened. They translated that, printed that, and distributed those news to other readers. By the mid-17th century, 16-something, it is estimated that political newspapers, which enjoyed the widest popularity, reach up to 250,000 readers in the Holy Roman Empire. Holy Roman Empire is Germany. And around 1/4 of the literate population. So by the mid-17th century, meaning that 1650, 1/4 of the population in Germany was literate, was able to read that newspaper, which is very high number. In England and France was well behind. According to my research, in 1750, after 100 years, 70% of the population was literate. 70% of the population was literate by 1750 in Holy Roman Empire, Germany. In England, it was like 40%. In France, it was like 35-40% again. But in Germany and the Netherlands, it was around 70%. The same level of literacy rate was obtained in Turkey in 1968. In 1923, literacy rate in Ottoman times were 7%, between 7 and 9%. It was 9%, but since people who were able to read was dead in the war, it was reduced to 7%. That probably excludes people who were able to read religious texts like Quran. So you were able to read Quran, but you were not able to read Turkish language, so it was considered as illiterate. Both in Ottoman alphabet. Mining is also another corner, technology and industrialization. Obviously, mines were there starting from Roman times or even before. There were coal mines, there were gold mines, right? But the problem was extraction, the speed of extraction. One technological advancement was hoist sensor. So water-powered mine hoist to raise mine from the underground, not by human power, but with water power, was invented about 1556. So they were trying to get something from the ground, like 30 meters, 40 meters, 100 meters, whatever. They were rolling it down and taking it up using the water power. O adama bir gün ben söyleyeceğim ama araba yıkıyor burada her hafta. Belki de her gün. Da Vinci and Takola created books, and those books are available today. when you look at those books, you can understand how they were thinking and what are the technological tools available in that time so that they can think about making certain devices, usually from wood and paper and basic mechanical and nails, etc. So, oops. In terms of mechanical technology, Leonardo da Vinci was quite a genius person. Also, maybe there were other genius people, but they didn't write. So only written documents were preserved, of course. Then we know Leonardo da Vinci as the one of the greatest inventors. Maybe there were other inventors, but they didn't write, and we don't know whether they exist or not. Next thing was, I said, compass, pusula. Sailing long distances was becoming possible. That led to European colonization of other continents. One, Americas, South America, North America, Christoph Columb, etc., Vasco da Gama, Magellan. So they traveled around the world. They found new routes to trade routes to China. China was like United States of those years in terms of production and GDP. So those goods will be traded to Europe through different routes because there were Ottomans in the middle. And also colonization of Africa and Americas, South America, North America became possible with long distance travel and navigation. And they produced maps, charts, so that navigators and captains were traveled with greater confidence. Then, first industrial revolution. Manufacturing was done by hand in the old times. But from hand production to machine was a big step. First industrial revolution covers the time between 1760 to early 18 something. Up to 1850, let's say. 1750 to 1850. When is the French Revolution? 1789. So it is before French Revolution and after French Revolution. So around French Revolution, we see first industrial revolution. That time includes going from hand production to machines, new chemical manufacturing and iron production, steam power, water power, and development of machine tools and rise of mechanized factory systems. So the factory concept became the fact in first industrial revolution. Before that, everybody was producing something at home. But after first industrial revolution, factories were built because production speed is increased at one certain mechanical setting, and that is called as factory to fabricate things. Before that, people were unable to feed themselves. Money was not good enough, so population was not rising. Since people produced more, they were able to get married more, they were able to make more child, and the life and because they were able to buy more food, they were able to make more child. So it also increased the population. That's what they say. That's interesting. I found it interesting. So it's directly related to population. One famous industry was textile. In the early times, textile was very common in Turkey, on Ottoman, and India. But in the first industrial revolution, Europe invented steam machine-supported textile industry and modern production methods, so that handmaking became slowly obsolete because speed was not fast enough. I'm going to show you something. So in the old times, yeah, this is interesting. Please watch carefully. This is at each cycle, the bird is going back and forth, left and right. 90 pick per minute. Modern machines does 3,000 per minute. 3,000, 5,000, 10,000. This technology is about, I think, 500 years old. Huh? Bir sağa bir sola. Bunlar da bir böyle bir böyle bir böyle bir böyle yapıyor. Bu sefer dokunmuş. Pastır gibi. İpliğin biri geçiyor gidiyor. Eliyle atıyor bunu. Otomatik hale geldiği için yazık bu arkadaşlara. Ya. Bugün bu. Tabii zannediyorum diye biraz havalı atıyorlar ürünleri. Belki de maliyet. Belki adama günde şu kadarlık para veriyorlar. Adam hala üretiyor bunu. Anyway, so this was the norm. But later, this is important. You see, there is a line here at the ceiling. Those ceiling lines are rods, and these are rotating drums. In the outside of the building, there is a steam engine or water mill. So there is a big rotating thing, single engine for the factory. So that power is distributed through rotating rods from the ceiling, and each machine gets the power from the ceiling by belts. So single machine for the single steam engine for the factory. Outside, someone is burning coal for the, but inside the factory, there are lines at the ceiling for power distribution. And then these weaving dokuma, these weaving machines run automatically without a person that we have seen a few minutes ago. That created, especially in the United Kingdom, a very significant trade power for selling to other countries. This is another setup for production of cotton fiber, I think. So this is the steam engine outside, and these are the power ports for each machine inside the factory. And steam engine this is, for example, a speed governor. It was regulated speed, so it rotates at constant speed by mechanical control using speed governor. Centrifugal force and gravitational force were balanced at some speed. So if you adjust that properly, centrifugal force and gravitational force match at certain rotational speed per minute, and that is satisfied all the time, because if you exceed that, those balls get further away and it controls the valve at the top, so it turns off the steam and so on. Tools. This is latte. Latte deyince kahve mi aklınıza geliyor? Latte. Bu latte torna demek. Yani bir malzemeyi takıyorsunuz, böyle çevire çevire işliyorsunuz. Bir de şey var, cutting var. O cutting'i de sağ sol yapıyorsunuz. Bir parça çıkartıyorsunuz. Onunla dişli de yapabiliyorsunuz. Çünkü biraz çevirip kat ediyorsunuz. Biraz çevirip kat ediyorsunuz. Bu sefer dişli yapabiliyorsunuz. Sadece satranç taşı, dama taşı yapmak için değil yani. Değişik şekilleri de tornada yapabilirsiniz. Cylinder screw cutting, vida yapabiliyorsunuz tornayla. Bir taraftan bunu yavaş ilerletiyorsunuz. Soldan sağa ilerletiyorsunuz elinizdeki katırı. Diğerinde çeviriyorsunuz. Bunu bir sürü yaptıktan sonra artık vida yapmış oluyorsunuz. O şeyi hep aynı şekilde yaptığınızda vida yapabiliyorsunuz. Machine tools made the economical manufacture of precision metal parts possible. Although it took several decades to develop effective techniques for that. Yani latte dediğinizde öyle o kadar da kolay değil. 1800'ün sonlarında İstanbul'da çekilmiş bir video var. Belki YouTube'da görmüşsünüzdür. Nargile yapıyorlar. Sultanahmet'te bir yerde. Görmüşsünüzdür belki. İpli tornalar var. Böyle döner şeye ip bağlamış şey gibi. Kemençenin yayı gibi. Bir tur attırmış ipe. Onu bir eliyle böyle yapıyor. İleri geri sallıyor. Diğer eli de bıçağı tutuyor. Nargilenin yuvarlak kafasını yapıyor şey. Dolayısıyla torna ama bir power'ı da elle. Bir eliyle power. Daha değişik yapanlarda bir başkasına çevirttirenler var. Diskli, çarklı çevirenler var. Dışarıda at yapıp attı döndürüp şu power'ı, bunların steam engine'den önce bunlar bir müzede gördüm Avrupa'da. At var. Atı döndürüyorlar. Atın döndürdüğü disk dönüyor geliyor neyse getiriyor bunu çeviriyor içeride. Bütün gün at orada döndürülüyor. Birisi de onunla ilgileniyor. Böylece içerideki çarklar dönmüş oluyor. Bir tane var. Ata şey yapmışlar.
Genelde eşek falan.
At vardı biblo. Yani ata şey yapmışlar. Yürüme bandı gibi, koşu bandı gibi bir şey yapmışlar. Rampada. O koşu bandının tekerinden almışlar enerjiyi. At sürekli yokuş çıkıyor. Yürüdüğü yer geri geliyor falan. Bağlı şeye. Bu şekilde bir power take-off device yapmışlar. Yani atın enerjisini şeye aktaracak. Üretim makinesine aktarmak için. Ha? Bilmiyorum. Ya, ediyordur herhalde. Yenisi geliyordur yani. Pes edince yiyorlar. Böyle double şeyi var. Um, so United Kingdom, Great Britain was interesting. This this is kind of complicated because Germany has its own religious renaissance. Britain has also its different religious uh, changes, including English Church. Along with that, the Oxford calculators and the mathematicians like Newton, etc., started British advancement in technology. Further, since Britain was island, Great Britain was an island country, they have to have ships. Therefore, it is improved over the years. Since they were able to make good ships because they had to. By mid 18th century, Britain was holding leading commercial routes, controlling global trading with empire with the colonies in North America, Caribbean, and major military and political hegemony in India. So they got India. Particularly with the pro-industrialized Bengal through activities of the East India Company. This East India Company, 17th centuries and 18th centuries, later as well, they occupied India not as another country. Rather, they established the East India Company. The company was, I wouldn't say owner, but company was responsible from operation of India. Yeah, that's correct definition. So, East India Company was the government of the India. The development of trade and rise of business were among the major causes of industrial revolution. So trade was increasing money, and money was fueling the technological revolution. And before industrial revolution, people were very poor. Life expectations were very different. After industrial revolution, food was more available, clothing, food, etc. So the life expectations of people were improved. Also, life expectancy also increased, of course, because of the nutrition. Average income and population began to increase. Some economists, this is important, some economists said that most important effect of industrial revolution was the standard of living for the general population. In Western world began to increase consistently, population began to increase consistently for the first time in history. Although others said it did not meaningfully improve until the late 19th and 20th centuries. So industrial revolution fed people of Europe. Otherwise, they were very poor. This is interesting. The terms of school, factory housing were invented during first industrial revolution. People were living because before they were living at home, they were working at home, they were doing some piece of work at home and going back to bazaar and selling. But after factories, machines were built, they thought they have to live closer to factory. So factories and houses were built together, like dormitories. Okay? And they thought there are childs, what will happen to child? What will happen to children? And they invented school for the elementary school, etc. So child care became an issue while the parents were working.
Çocukları başlarına
Evet. Savmak demeyeyim artık da anne baba eğitecek ortam ortadan kalkmış oluyor. Bu bunlarca yılda yavaş yavaş olan bir şey. Ama fabrikaların yanında ev olayı var. Yani hatta fabrikanın sahibi yurt gibi evleri yapıyor. Çalışanlar da orada yatıp kalkıyor aileleriyle beraber. Çünkü bilmiyorlar şeyi. Nasıl olacak? Yani bir fabrika yaptık ama insanlar uzaktan nasıl gelecek? Yani gelecek mi, gelmeyecek mi? Nasıl bir şey olacak? Dolayısıyla orada yaşamaya komünite olarak yaşamaya başlıyorlar. Bu şekilde. İngiltere'nin bütün kentleri bu şekilde gelişiyor. Fabrikaların etrafında gelişiyor İngiltere'de ve maden ocaklarının etrafında gelişiyor. Bugünkü şehirlerde aynı. İşte onu söyleyeyim. Rather than having individual workers spread out in their homes and workshops, factory was a large central place where many workers came together and make products. Factories were necessary because machinery was expensive, large and needed both power and many workers to be operated. Yani bir makineyi birden fazla insan yapıyor ki ev ortamı gibi olamaz. Bugün, today, we are seeing the opposite. We are starting to, as you are taking this course from home, we are starting to get back to homes for certain type of work. We are going back to original. Second important part is division of labor. Different workers each have specific tasks in making the one product. Each worker can specialize in one small task function that doesn't have to know how to make the entire product. So entire product is the combination of multiple workers in harmony. Ne? Söyle. İşte mi? Evet, olabilir. Mantıklı. Adam neyi düşünecek? Bir icat yaptım. Bundan işte dokuma yapıyorum. Herhalde askeri düzende işçileri çalıştırıyor. Evet, doğru. Bir başlarına bir işte şey koyuyor. Ustabaşı koyuyor. Bilmem ne koyuyor. Aslında o ordu şeyi oluyor. İşçiler oluyor. Değil mi? Doğru söyledin. Oluyor zaten. Evet, tabii. Ama karnın doyuyor. Many of the workers could be unskilled workers because they only needed to be taught one simple task and they would repeat over and over. Almanya'ya giden işçilerimizin vaktiyle şey yaptığı durum. Ve at the same time there were migration from villages to cities in the first industrial revolution in England and Germany and Netherlands. Third, parts are standardized. Previously, for example, screws were not standard. Each usta has his own screw set, because he is making by himself. But then, with the factory work, parts become standardized. So this concept eventually led interchangeable parts where individual parts could easily be replaced and repaired from other new manufactured parts. Iron industry was boomed in Britain. Before that, bar iron was the commodity form of iron used as raw material for making hardware goods, such as nails, wire, hinges, horseshoes, because iron was available before, demir çağı, etc. So iron was available, but the problem is producing it in large quantities and making of steel out of iron. Steel and iron is different, and making steel using not only hand process but also the factory using factory process. Cast iron was used for pots, döküm, stoves and other items where its brittleness was tolerable. Kırılganlığı tolere edilebilir. Most cast iron was refined and converted to bar iron with substantial losses. Bar iron was also made by bloomery process, which was the predominant into iron smelting process until the late 18th century. Demir dövüp tekrar yakarak içindeki karbonu yakıp çeliğe çevirme elle demircilerde olabiliyor. İşte kılıç mılıç öyle yapıyorlar. Yani demiri çeliğe doğru dönüştürme elle oluyor o zamana kadar. Bar ayrından, bloomery prosesten yapılıyor. Isıtıyorsun, dövüyorsun, ısıtıyorsun, dövüyorsun.
Ne yapıyoruz?
İçindeki karbonu çıkartıyor. Demiri kırılgan yapan karbon. Karbon miktarı azaldı mı çelik oluyor. Belli bir seviyede. Daha da azaltırsan gene bozuluyor. Çeliğin karbon grafiği vardır malzeme dersinde. Ereğli Demirçek'te falan büyük fırınlar var. O Bessemer, İngiltere'de bulunan proses. Alttan yakıyorlar çok büyük sıcaklıkta şeyi. Üstten demiri atıyorlar. Cevheri. Yakıyorlar resmen. İçindeki karbonu yakıyorlar. O yanarak çıkıyor. O zaman alttan şeyi akıtmış çeliği akarak alabiliyorlar.
Tamamen,
Çok basit söyledim de öyle o kadar basit değil tabii. Onun derecesi var, mühendisi var.
yani tamamen çıkarmak mı?
Evet, o zaman tekrar kırılgan oluyor. Bir böyle U şeklinde grafiği var. Tam istediğin yerde istediğin çelik değeri oluyor yani.
Eskiden nasıl yapıyorlar? Ölçülü bir yöntem.
Isıtıyor ocakta, dövüyor. Isıtıyor, dövüyor. O ısıtma dövme sisteminde karbonu atıyor. O yüzden demir dövücüler demiri çeliğe çeviriyorlar.
Peki yani nasıl doğru seviyeyi anlıyorlar?
Tecrübe herhalde. Kimin kılıcı öldürüyorsa o onunki doğru diye. Iron industry in 1720 there were 20,000 tons of cast iron. Bak bu önemli. 20,000 of cast iron using charcoal and 400 tons with coke. Coke is the coke kömürü. Higher grade. Charcoal is mangal kömürü. Okay? Because you need high temperature for smelting. Still, 20,000 tons is very big number for those years. In 1750, charcoal iron production was 24,000 and coke iron was 2,500 tons. So coke iron was increasing. In 1788, charcoal cast iron was 4,000 tons, while choke iron increased to 54,000 tons. In 1806, charcoal cast iron production was 7,800 and coke iron was 250,000 tons. In 50 years' time. So it is a lot of time. Beyond one generation retired. It's like 1970s and now. So 50 years difference. Mangal kömürü inefficient. Yani kok kömürüyle yapılıyor. Madenden çıkan kömürle yapılıyor. Öbürü elle. Demircilerin usulü. Charcoal. Demirci yöntemi azalırken onu söylemek istiyor. Endüstriyel yöntemle üretilenler artıyor. Another issue was child labor. In the older days, in medieval times too, people were slaves, basically. There were free people, there were not free people. Not free people, regular peasants, etc. They had to work, so their children also had to work. They were working in very bad conditions. With the Industrial Revolution, child workforce was considered as a very cheap labor because families were making a lot of children, and they were unable to feed them. So they had to work, and they worked in mines because they were small. Children were working in mines and other processes. In all parts of the industry. For example, in the United States, there were over 700,000 children under age of 15 working. In over 50% of the workers in the British factories in early 1800s were under 14. Yani öyle şaka değil yani. Yani sütten çıkmış ak kaşık değil yani. Kopenhag kriterleri falan. Biraz 1800'den bahsediyoruz. 100 sene önceden bahsediyoruz ama bunlar yaşanmış yani. Biz de aynı şekilde. So through that there were social movements as well. There were social movements as well. Worker classes were very poor, whereas businessmen were gaining a lot of wealth and power. That will lead to worker movements and asking for more payments. Therefore, late 1830s and early 1840s, early innovations were saturated. Mechanized spinning and weaving dokuma. So their markets matured. Their markets increased and stabilized, so there was a slowing down. Innovations developed in this period, such as the increasing adoptions of locomotives, steamboats, steamships, hot blast iron smelting, and other technologies such as electrical telegraph, widely introduced in the 1840s, 50s, were not powerful enough to drive high rates of growth. There were technological advancements, but growth rate reduced because they were unable to sell. Basically, they were unable to sell their goods to other people. It's finished. Textile is finished. It was basically textile. So there was a stabilization time going down. That ends about first industrial revolution. Working conditions. Again, I'd like to show these. These again, children were working on top of moving conveyor. They were separating rocks and coal. If there are rocks, they will clean it. So that kind of man cleaning power. Ayıklama yapıyorlar. Taşları ayıklıyorlar.
Neyden?
Kömür. Alttan bant geçiyor. Geçerken içinden taşları alıyorlar. Yan tarafa koyuyorlar, öyle bir şey. Bir yerden alıp öbür tarafa koyuyor, öyle bir şey var. Okudum yerleştirirken de sonra unuttum şimdi. So working conditions for women exactly as follows. So these are the British factories generally and United States factories in those years. Further, accommodation of women in workforce was high, unlike Ottoman case. Women workforce was used. This is Netherlands, a bicycle factory. Again, the power is coming from the ceiling, from the top, mechanically. And after 1870, that's about Russian war with Ottomans that time. A new group of innovations started second industrial revolution. That innovation included new steel making process, mass production, assembly lines, mass production and assembly lines, electrical power, large-scale manufacture of machine tools, and use of increased advanced machinery in steam-powered factories. One very important crucial factor is the electrical power, second industrial revolution, electrical power and assembly lines. Assembly line approach and electrical power is the key. The rest is important, but not that important. World manufacturing output was in 1860, 1860, and 1900. Rest of the world, especially China and Ottoman Empire and India, Ottoman Empire, India and China was providing production 73% of the world at this time. Later, in 50 years, Europe increased, United States little bit increased. So at the time of George Washington and Albert fights and the colonization time, when British were invading 200 years, British were invading continental America, Mexico, etc., French also. They were only doing farming, or they were just occupying those places. Later they started production. So the main production was in Europe after the first industrial revolution. Rest of the world diminished significantly. China. It didn't diminish, it stayed the same. So the ratio became insignificant. Japan was also something significant, and it lost certain significant part of the economic output. One important thing, Japan was a producing country even before Second World War and First World War. So Japan was an interesting country even before. So years before, Japan was an important country. One interesting thing was with Japan, one king. How do we call Japanese king? Emperor, yeah. Japanese emperor said, we are not going to make interaction with foreigners. I think in those years, they closed connection with the Dutch sea tradesmen. So they preserved their culture, I think about 200 years or so. So it was internal development. They opened their doors to rest of the world after some emperor decides that we should get interaction with the other countries. Then they started interacting. At that time, for example, their clock system was different. Last lecture I said that. Their measurement system was also different. Yanlışlık ettim. Son slayda mı geldi? O halde. Typical British city was like this. London, Glasgow, the famous cities were like this. There were people dying every day due to pollution. This is also London. Chimneys were a very important figure of city skyline. Chimneys, factory chimneys. And at that time, all theories of Copernicus, Galileo, Huygens, Newton were restudied. With the scientific revolution, first classical antiquity, Greek time ideas were replaced by the ones with Galileo, Copernicus, and Newton. But after first industrial revolution, further studies are done on top of that. So Newton, for example, Newton theories were also improved and restudied. In 19th century, 18 something, practice of science became professionalized, universities and institutions and societies, in ways that it is continued through 20th century. So through institutions. The role of scientific knowledge grew in society, and then it became incorporated in many aspects of the functioning nation states. So nation states tried to establish their own science producing and technology producing institutions. Not like TÜBİTAK and the National Science Foundation, but more like universities and societies and industrial societies, etc. More like societies at the beginning. Later, after Galileo, Newton, etc., physics and chemistry, those areas were studied in more detail. One of them is Huygens. He studied magnetism, forces, centrifugal forces, etc. Yes. Inertia, electricity. So he found out that Earth is magnetic, etc. In 1687, Newton published his book Principia Mathematica. You can find it now. You can download it and read it if you are interested. So it contains Newton's law of motion, gravitation, and gravity and forces and kinematics, all of them in one book, Principia Mathematica. What else? We had Galvani, Aldini, Volta, Faraday, Ohm, and others. Volta, I have shown the picture last time. He was demonstrating his battery to Napoleon. Faraday again with the electricity. Ohm was working on electricity and resistance, of course. Those studies led to unification of two phenomena into single theory of electromagnetism by James Maxwell. So Maxwell combined a lot of things into one and described theory of electromagnetism, electromagnetic waves, etc. in theory. Then in beginning of 20th century, Max Planck, Albert Einstein, Bohr, etc., studied further and studied in atomic levels, and they study quantum theories, etc., space-time relations, etc. Let me show something. They make conferences, for example. This is interesting picture. Some names you may be familiar with. Einstein is here in the middle, right? Madame Curie is on the left, only woman. Let me show Picard, Schrödinger, Heisenberg, Bohr, Broglie, Dirac, Planck, Lorentz, Einstein, Wilson, Richardson, Bragg. So these are the guys at the turn of the century, around, this is I think 1911. They were studying physics. Okay. So these guys, 1900, Planck, Bohr, and in the conference they studied, as I said, the quantum theories and the atomic theories in chemistry. Schrödinger, Heisenberg studied quantum mechanics, quantum theories. Observation of Hubble in 1929 said galaxies move in a certain speed. Oops. Galaxies move at certain speed, so their distance is correlated with their speed. So there might be a Big Bang happened 5 billion years ago or so. Formulation of the Big Bang theory by George Lemire followed Edwin Hubble. Bohr worked on gases, nuclear reactions, and electricity. Ernst Lawrence in 1930s also worked in physics and nuclear reaction. Later resulted in invention of the atomic bomb and so on. So biggest nuclear technology advancements were invented in theory in the early 1900s, beginning of 1900. So quantum theories and solution of equations, etc. Early experiments of radioactivity, they were all done in Kurtuluş Savaşı, all those times, early 1910s and 1920s, First World War times. This is again from the Solvay. Yeah, this is from the Solvay conference. This is from 1911. The other one was later years in color. This is black and white picture.
Yeah, both Solvay.
Yes. They are still holding the Solvay conference today, physics conference, for selected researchers. And there was a guy named Solvay, a very rich person. So he invited physics professors to the same place every year to study.
Where are they? Where are they?
I think in Belgium, I think. That was a good question. I mean, I don't know where this. This is the guy Solvay. Rich guy.
Sadece zengin mi yani? Bunun bir şeyi
Ya
var mı?
işte bilimi seviyor falan filan.
Fransızca da
Brüksel, Belçika'da. Bak 2016'da Brüksel'de yapılmış. Gene böyle. Bunlar da bugünküler. Anlatabiliyor muyum? Bu işte ilk konferans. Nerede? Solvay Enstitüsü. Poincare'ler, şunlar bunlar hepsi var. Kimya şirketinin sahibiymiş. Zengin tabii de. 5. konferans 27. Öyle o kadar. Solvay. I think I am done for today. So today we worked in technology rather than science. So how technological advancements were happened and first industrial revolution